Hello, students. Welcome to Lesson 6, Analyzing Graphs. This is of Unit 5 in your Algebra 1 student workbook, page 321 in Illustrative Mathematics by Imagine Learning. Let's look at our lesson objective for today. We're going to be comparing situations where quantities are changing exponentially. Remember that for something to change exponentially, we're looking for it to have a common factor or a common ratio, the same thing that we're multiplying each time. If we see that common factor, that common ratio, we know we have an exponential. So they start out with a warm-up, fractions and decimals. And again, this is just a quick reminder of how we convert between the two. And then let's look for patterns. In the table, find as many patterns as you can. Use one or more patterns to help you complete the table. Be prepared to explain your reasoning. So we're looking for sentences here of what you saw as your pattern with your reasoning. Pause the video here, and with your table mates, please see what patterns you can come up with. Okay, let's see how you did. So hopefully you noticed that we started with a 1/2, and that's been converted into the decimal of 0.5. We started with 1/4, converted to 0.25, 1/8 to 0.125. Now, how can I actually do that on the calculator? Hopefully you experimented and you were able to realize we could just take the top number typed in first, divided by 16. And so what's actually going to go into your calculator would be a 1 divided by 16, and then a 1 divided by 32. Those are the buttons you're going to hit on your calculator. If you do that, it should show you the decimal version of each. Pause the video and try that now if you did not already. So what did you get for the decimal version for each? For this one, you should have gotten 0.0625. And then when you typed in the second one, 0.03125. Now, if you weren't just using the calculator button, maybe you noticed the pattern. Maybe you realized that you saw that it was jumping from here to here and from here to here as multiplying by 1/2 or times 0.5 or dividing by 2. All of those things mean the same thing, so let's write that out. This is known as our common factor. Well, if you look at the top row, it's going by the same thing. If I multiply 1/2 times 1/2, I also get 1/4, 1/8, 1/16. So maybe you just continued the pattern and saw that it went to 0.0625 and 0.03125. All right, let's type out a couple of sample responses that you could have put for this section with your groups. What did your group say? Did your group say times 1/2? Did your group say times 0.5? Or did they say divided by 2? All of those are correct. Let's look at something else your group may have been able to say. Maybe you said something like, did you notice that the decimals were in powers of 5? Did you possibly notice anything about the decimals written as 5/10? Like 0.5 is the tenths place, so I could write that as 5/10. 0.25 could be written as 25/100. Did you notice that the fractions We're in powers of 2 in the denominator. Anyways, any of these things that your group noted or noticed or anything else that I didn't mention, beautiful job. Make sure you have something written up with your explanations here on this warm-up. We're now moving on to the 6.2 falling, falling. This first graph, graph A, we've actually seen before already in previous sections. And then we've got a new graph, phone B. We're comparing value of some cell phones that are changing exponentially after their initial release. Here are the graphs showing the depreciation. So we talked already about cars depreciating. Now we're talking about phones that depreciate. What does that word mean again? You got it. It's when something loses value, it's going to have a value that's a fraction of its original value. So when I look at this first graph, you already should be thinking of the work we did in a previous section where I see those outputs of 600 versus 100, of 360 versus 600, and we're going to be comparing those outputs in a ratio form to see what the multiplier is here shortly. And then on this new graph that we've never seen before, again, I'm already taking note of the initial output compared to the second output, time 1, and then here and here. So we'll be comparing those as well. Which phone is more expensive to buy when it's first released? So again, this is asking us to compare the vertical intercept, the starting value of that phone. And so if I look up here, I see the first phone is at 0, 1000, phone A, and phone B is at 0, 840. So we would say phone A starts at a value of 1000. And phone B starts at a value of 840. Again, where did that come from? That came from that initial value, that starting point, that vertical intercept on the graph. How does the value of each phone change with passing year? Again, like we mentioned right when we were looking at the graphs, we're going to want to try to calculate the common factor of each. What's the remaining value of each year to year? So on phone A graph, which we've done this work before, we're going to be dividing 600 divided by 1000, the two outputs I highlighted in yellow, and then 360 divided by 600. So we're going to go, so please in your calculators do 600 divided by 1000. What does that give us for a common factor? And then 360 divided by 600. Then for the second one, I'd like you to do the other outputs of graph phone B. So 630 divided by 840. And the second one is going to be 472.5 divided by 630. I'm again looking to make sure these are common factors. They give me the same number here, and then that'll show you how each phone is declining in value. The depreciation rate. All right, I'm grabbing my calculator. 600 divided by 1000. Hopefully you guys got 0.6. 360 divided by 600. Hopefully you got 0.6. So phone A has a depreciation rate of 0.6, or 0.6 is the remaining value of the phone after each step. Next, 630 divided by 840. I'm getting 0.75. So this one's retaining more value. 472.5 divided by 630. 0.75. We always want to check at least 2 to make sure it is a common factor. Another way of representing these could have been in fraction form. So phone A, how else do I say 0.6? That's like 6/10 or 3/5. Phone B could have also been represented as 0.75, right? So as 3/4 as the fraction. Which one is falling in value more quickly? Explain how you know. Phone A has a lower remaining value of 0.6 versus 0.75. So phone A is falling faster than phone B. Remember that you do not need to type my words exactly. You should be putting this into your own words. You could have said it differently. You could also say that 0.6 is a lower remaining value than 0.75. Okay, if the phones continue to depreciate by the same factor, what will the value of each phone be 4 years after its initial release? And so it would be helpful to have an equation um, in order to plug this into. So number 4 usually leads us into number 5, writing the equation. So let's start with phone A on the left. It's telling us below what letters to use. V for the value and W for the number of years. So we would say V equals, beginning value was 1,000, depreciation factor of 0.6 to a power of time. And they're asking us to plug in a time of 4 years. So take a minute to calculate that one for me. Phone B starts at a value of 840, has a factor of 0.75. Again, they're having us plug in 4 years. Take a minute, grab that yellow calculator, and type that in. All right, when I plugged in 840 times 0.75 to the power of 4, did you guys get $265.78? And then for the first one, 1,000 times 0.6 to the power of 4. Again, where did this 4 come from? They're asking us to plug in 4 right here in the question. Did you get 129.60? So notice that as we said in the previous example, phone A is losing value more quickly. Now it wants the full equation. So we already wrote it in the step before where we're just going to, instead of using a power of 4, we're going to put it for all time t. And so we write V equals 1,000, 0.6 as the factor, power of t. That's phone A. Phone B, V equals 840, factor of 0.75 to the power of all time t. You may have already had that answer up written under number 4. Okay, that's it for the lesson today. If in class we did the card matching, the card sort, these cards are passed out and you're just supposed to find with your partners, with your table mates, with the class, which ones go together. So you can go based on a couple things. What are they starting at the vertical intercepts? Are they increasing or decreasing? Is the growth factor greater than 1 or less than 1? And what is that factor of increase or decrease? Does it match the card? So you can match these in a couple of different ways. Great job on the lesson. That does it.